Welcome all to today's training session. Today's topic is Basic of Blanking Dies. Myself Praveen. We are going to learn fundamental about blanking dies. Blanking die is a equipment used to cut sheet metal as per required profile. Contents: different element of dies, shearing theory, strip layout, formulas and nomenclature of strip layout. It covers scrapage, pitch, strip width, cutting clearance, cutting force, stripping force and press force. Let us briefly discuss about different element of press tool. Punch and die are cutting elements of blanking tool. These are male and female elements with required blank profile. Normally punch is mounted on top tool and die is mounted on bottom tool. Element which hold the punch on top plate is called punch holder or punch retainer. Coming to stock, it is a sheet metal in the form of strip or coil from which we cut and extract our blank or component. Next is stripper, element which holds the strip during cutting and eject from the punch after cutting, which is called stripper plate. In addition, there are some standard elements like stripper bolt or strip retainer, screws, dowel, screws to hold the elements and dowel to guide the elements. Stripper plate is mounted with a spring which help to eject the strip. Now we will discuss in detail about each elements of the press tool. First major element of press tool is a die set, which involves top plate, bottom plate and guiding elements. Guiding element involves our guide pillar and guide bush. Let us discuss about each element of die set. We will start with the top plate. As name itself indicates, it is a upper plate which holds entire top assembly of the die. It may be made up of mild steel or cast iron. It holds different elements like punch, punch holder, floating stripper. Next is bottom plate. It holds bottom assembly consists of die plate, fixed stripper and backup plate. Next is guiding element. Guiding element which guide the top assembly to the bottom assembly for proper cutting. If pillar set is provided in top assembly, bush set will be provided in bottom assembly. If bush set is provided in top assembly, pillar set will be given in the bottom assembly. Next is punch holder. Punch holder is a die element which holds and retains the punch back after its operation. It is also known as a punch retainer because it retains the punch back to its original position after cutting operation. Now another important element of press tool is stripper plate. Stripper plate is the element which holds strip during cutting and eject the strip after cutting from the punch. Based on the requirement and sheet thickness to be cut, there are two types of strippers are in use. First one is a fixed stripper, another one is floating stripper. Fixed stripper is used for higher thickness sheet where high ejection or stripping force is required. Normally fixed in the bottom, that's why it is called fixed stripper. Next is floating stripper. Floating strippers are traveling strippers, travel with top die and ram, which is a spring loaded stripper normally used where lower ejection or stripping force is required. Next is backup plate. It is a hardened plate which takes point load coming from punch and die plate during cutting operation. Upper and lower black shaded part in the drawing. Shearing theory. Shearing theory is a core of this training session. Please understand carefully. If required, pause and watch the video again. Now, how much time does it take to shear a sheet metal of 2 mm thickness? It's less than a microsecond. It is in a microsecond. Let us divide this microsecond into 3 nanoseconds for better understanding of shearing theory, and we will discuss the theory in 3 stages. First, plastic deformation. Second, penetration. Third, fracture. Plastic deformation is a pre-shear stage where sheet metal deform up to rollover depth. You can see a minor radius on sheet at a first stage. Next is penetration stage. Further increase in load leads to penetration of punch into sheet metal. stage is called penetration stage. Vertical shining band appear in cut edge at this stage is called a cut band. Third stage is fracture. When load is increased further leads to separation of component from the mother sheet. The stage is called fracture stage. Blackish rough surface appear on cut edge during fracture stage. In blanking, burr will be on punch side, radius will be on die side. To summarize further, deformation stage radius is formed, penetration stage shiny cut band is formed, fracture stage blackish rough surface is formed. We will discuss about strip layout and various nomenclature of strip layout. An effective component layout on a strip or coil is important to achieve a higher yield. Intention of designer should be maximum utilization of a stock in component form, that is maximum yield need to be achieved in design stage. We will discuss different nomenclature. First is scrap bridge. Stock which holds and connects the adjacent components in strip layout. In progressive die, the component is connected with coil or strip till its last stage through scrap bridge. Next is blank width. It is the width of the component need to be cut. It is again depending on the component drawing. Next is pitch. Pitch is blank width plus scrap bridge. Next is strip width. Strip width is nothing but a blank width plus 2 times scrap bridge. In sketch you can see two components, two blanks. Between there is a stock which we call as a scrap bridge, which connects the two adjacent components. The product or blank width, product width you can call as a blank width. When you add blank width to scrap bridge, it becomes our pitch. Then come to strip width. Blank length you can observe here, and both the side there is a scrap bridge. So blank length plus 2 times scrap bridge will be considered as a strip width. Let us discuss some basic calculation about the press tool. First one is cutting clearance. What is the cutting clearance? Cutting clearance is the gap between punch and die in closed condition. Why this gap is required? For a proper cutting, there is a minimum gap required based on the sheet thickness and tensile strength of the material. Formula is C into S into square root of T max by 10, where C is a constant 0.01, S is a sheet thickness, T max is a maximum shear strength of the material. If grade is 980, then 980 you can take directly as a T max. Next is cutting force. What is cutting force? Force required to cut the periphery given in the design. How it is calculated? Cutting force is equal to L into S into T max, where L is length of periphery. If we take a 10 by 10 component, length is 10, width is 10, then periphery becomes 40. L equal to 40 mm. S is a sheet thickness, for example 2 mm. T max is a maximum shear strength of the material, that is example what we have taken is 980 grade. 980 we can take as a T max. Next is stripping force. Stripping force is a force required to eject the strip from the punch after cutting is completed, cutting operation is completed. Normally it is considered as a 20% of cutting force, that is 0.2 into cutting force we take as a stripping force. Coming to press force. Total force required for the press, that is cutting force plus stripping force plus 30% of cutting force is calculated as a considered as a press force. I will repeat stripping force and press force once again. Is stripping force. 20% of a cutting force, that is 0.2 into cutting force we take as a stripping force. Next is press force. Cutting force plus stripping force plus 30% of cutting force will consider as a press force. Thank you for watching the video. Namaste.